Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra class. Today we are continuing with our quadratic saga, and today we're going to learn how to solve quadratic equations by factoring. Now, before I teach you how to do this, I just have to show you exactly why it is that we're doing this. I think that's going to be much better for you to get an understanding of why is Mr. Morrow making us do this. If I were to tell you solve, let's say y equals x squared, let's say minus 2x, and let's say minus 3, okay? We know that we first find the axis of symmetry, and the axis of symmetry is an x equals negative b over 2a equation. So x would equal negative times negative 2 over 2 times a, which is 1. So x would equal 1. I know step 2 would be my vertex. My vertex is the negative b over 2a value for the x. You plug that value into the function and find y. So 1 squared minus 2 times 1 minus 3, in this case, is going to be 1 minus 2, which is negative 1, minus 3, negative 4. Step 3, you find your y-intercept, which is the y value when x is 0. And that would be my y-intercept, right? Everyone's with me there so far? Okay. So I'm basically here. Let's go ahead and take this. And let's just put this over here since we know what's going on there. And now let's graph it. We've got my axis of symmetry at 1. My vertex at 1, negative 4. And my y-intercept is 0, negative 3. That's 1 to the left, you go 1 to the right. Now at this point, you go like that, right? Correct? Now, the solutions to this function are these x-intercepts here, right? Those are the zeros. They're x-intercepts. They're also known as solutions. You guys with me there? Now, here's the problem. When I made this curve, I made it like this. Some of you will make it like this. Some of you will make it like this. Which one is right? No, not all of them. If it was all of them, then that means that the x's could be that, that, or that. No. Thank you. Good thinking. But to be honest with you, we don't know. So today, we're going to solve for x. And you're going to actually find the real values. If I go ahead and factor this. What times what is negative 3, but when added together is negative 2? It's negative 3 and positive 1. By a property called the zero product property, I'm going to teach you that in a second, you're going to find that x equals 3 and negative 1. So these are my zeros. And that is the proper graph. So what we're doing today, it has everything that we've learned up to now, but now it's adding the actual solutions. We're going to solve for the solutions algebraically. We're going to know what they are so that we can really graph it truly accurately. Does that make sense? That's what we're doing today. Sir? I don't understand what that means. You mean every point is symmetrical? Yes, but when you're solving, you find both. Okay? Now, let's get to the lesson. We know already quadratic functions are in the form of y equals ax squared plus bx. We know that. Where y is the dependent variable and x is the independent variable. We know that a and b are coefficients, which we will investigate later. Actually, later already happened. The a, as you know, If it's greater than 1, it determines that the graph is going up. If it's less than 1, it determines the graph is going down. If A, the absolute value of A is greater than 1, it's a vertical stretch. If the absolute value of A is greater than 0 but less than 1, it's a vertical compression. We know that C is the y-intercept. Notice, please, that the degree of the polynomial is 2. That's how we know that it's quadratic, because it has a degree of 2. We know that when we graph quadratic functions, we get parabolas. Parabolas are these U-shaped graphs. Okay? And the points where they cross the x-axis, the x-intercepts, are the zeros or the solutions. In this case, it'd be negative 2.3 and 1.3. In this case, when the A is negative and it's pointing down, my solutions would be x equals negative 6 and x equals 4. Those are my solutions. So again, when you graph it, you're solving the equation by finding where the x-intercepts are. Today, we're going to learn how to do that without graphing. Again, the points at which the parabola crosses the x-axis are the solutions of the quadratic function. In other words, the x-intercepts are the solutions of the quadratic function. Everyone understand me so far? Now, sometimes, not all times, there are a few different ways to solve quadratic functions. Today, we're going to learn how to factor them. Tomorrow, we're going to learn the square root method. And then on Monday, we're going to learn the quadratic formula. But sometimes, we can find solutions of the quadratic functions by factoring and using the zero product property. I briefly explained the product property. Let me really teach it now. Zero product property states that for any real numbers, A and B, if A times B equals 0, then either A equals 0 or B equals 0, or both of them equal 0. So what does that mean, Mr. Morrow? Well, when I factor a trinomial, I'm going to be left with a binomial, two binomials, just like here. We could call this first factor my A, call this second factor my B. In order to find the solutions, I set my A, which is x plus 3, equal to 0. And I set my B, which is x plus 2 equals 0. And my solutions would be x equals negative 3 and x equals negative 2. Now, what does that tell me, Mr. Morrow? That tells me that on this graph, negative 3 and negative 2, those are the x-intercepts. I know that this graph is going to be pointing upwards because x times x is x squared. That's positive. So it's going to look something like that. That's not the exact graph, but that's what you should be visualizing in your head. When you find these solutions, you're finding the x-intercepts. Is everyone with me so far? Guys, talk to me, please. Yes, sir. I solved, son. X plus 3 equals 0. How do you solve for x? You subtract 3 to both sides. If you guys are having problems with solving single-step equations, I suggest strongly that you watch my video on single-step equations. Yes, sir.
So whatever your A and B are, however many.
You set all of the factors equal to 0.
I'm a calculus that takes to get to 0. That's like that's what your x's are gonna be, zeros.
Yes, correct, sir. You got to solve for x, and you set them equal to 0. And you solve by undoing the property that is given to you. For example, what are the solutions of the following equation? They already gave it to you in factored form. Well, this is my A, this is my B. In order, this is my A, This is my b. In order to solve this, you have to use the zero product property. So that means you set 4x plus 1 equal to 0, and x minus 2 equal to 0. So in this case, subtract 1 to both sides, divide by 4. So x will equal negative 1/4, and x would equal positive 2. What does that tell you? That tells you that on a graph, the solutions to that graph are going to be at x is negative 1/4 and x equals 2. And the graph is going to look something like this. Does that make sense? Are you understanding where this is going? Okay? What are the solutions of each equation? I've already factored them for you. So this will be the last step before the zero product property. So in order to find the solutions, you set every single factor equal to 0. You set every single factor equal to 0. So in this case, x will equal negative 1 and 5. Good. For b, x will equal, bless you, negative 1/2 and negative 14. For example, c, n will equal 4/5 and 2/7. Excellent. For letter D, the solutions are x will equal, no, negative 3/2 and 4. So once you have factored the trinomial and you are left with two binomials, set each factor, each binomial, or monomial, depending on what you have, set each one equal to 0. For example, what if I told you that this was my factored form? What would the solutions be here? X will equal 0, and x minus 5 will equal 0. So x would equal 0 and 5. You set every factor equal to 0 in order to solve quadratic functions that you can factor. Does that make sense? Let's put it all together. Whoa, wrong way. Okay. Now, what are the solutions of the equation? Okay, now we got to do the whole thing. Let's factor. What times what is 15, but when added together is 8? Positive 3, positive 5. So what are my solutions? X is going to equal negative 3 and negative 5. Now, just so you could see how awesome this is, okay? Let's just, for giggles, graph it. Because I'm not skipping 8/5. I'm just putting 8/5 together with 8/6. 8/5 shows you how to graph to find the solutions. But it shows you how to graph and find the solutions before you learn how to factor. So it makes it a little bit more difficult. So for right now, we know already that 1, 2, negative 3 and negative 5 are solutions. Correct? All right. Let's find my axis of symmetry. My axis here is negative b over 2a. So x equals negative 4. Let's graph it. Let's find my vertex. My vertex is negative 4 comma, well, negative 4 squared is 16 minus 32 plus 15. So that's going to equal negative 1. So negative 4, negative 1. You with me? And guess what, guys? That's my graph. Let's say you want it really accurate, like really accurate. Find the y-intercept. What's the y-intercept in this case? 0, 15. Let's go by intervals of 3. 3, 6, 9, 12, 15. That's 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. That is a perfect parabola. Does that make sense? Sure. I'm sorry, my brother? You mean the average? Yes, but instead of doing the average of the x-intercepts, just find the axis. But yes, yes. Does that make sense, people? So again, am I asking you to graph this on this homework? No. Why are you doing it then, Mr. Morrow? So you can see what it is that we're finding. All we're finding right here is this guy and this guy. And if I ask you to graph and solve, what do? You find the axis, you find the vertex, you find the y-intercepts, and you find the x-intercepts. Graph them all, mirror images, boom. You're done. Does that make sense, guys? You promise me? Thank you. Let us continue, please. Okay, let's solve. What times what is negative 14? But when added together, it's negative 5. Negative 7 and 2. Oh, yeah, nice. Okay, what times what? I'm not done. What does m equal then? Sorry. Negative 2 and 7. Very good. Here, what times what is negative 20? But when added together, it's positive 1. Positive 5, negative 4. So what are my solutions? P equals, said each of these equal to 0, guys. 4, negative 5. Very good. Now, I have a cubic method here. So 2x, 2x. 2 times 18 is 36. What times what is 36, but when added together is 15? Negative 15. Excellent. Negative 12, negative 3. Artificial factor, x minus 6 times 2x minus 3. Now, my solutions. X is going to equal 6 and 3 halves. Remember how I promised you that you had to know factoring? Here you go. Mr. Morrow does not lie. May I continue, gentlemen? We all understand what we're doing, gentlemen? Okay? What are the solutions of each equation? Okay, now, sometimes they don't give it to you already in standard form. So, if they don't give it to you in standard form, what do you think you have to do? Put it in standard form, thank you. So, subtract 18 on both sides. 4x squared minus 21x minus 18 equals 0. Cubic method. 4x, 4x. 4 times negative 18 is negative 72. What times what is negative 72, but when added together is negative 21? Guys, got to work on this. It's going to be negative 24 and positive 3. Artificial factor of 4. So x minus 6 times 4x plus 3 is what I'm left with. So what are my solutions? What does x equal? 6 comma negative 3/4. Is everyone seeing how I do this? You promise me. Okay, number 2. What times what is negative 54, but when added together is positive 3? Positive 9 and negative 6. So what are my solutions here, gentlemen? Negative 9 and 6. Very good. Next. Is this in standard form? So I got to add 49 to both sides. X squared plus 14x plus 49 equals 0. What times what is 49? But when added together is 14. Okay. Well, so what's my solution? Okay, you don't have to write negative 7 twice. Let me explain why. Let me explain why. You can only graph once. Yeah, this says, remember, parabolas, guys, can have two solutions, right? Or if they're going down like this, two solutions, can have no solution, never hits the x-axis, or it can have one solution. In this particular case, how many solutions does it have? One. So let's graph it so you can see what it looks like. We already know my x-intercept. That's negative 7. So that's right here. Yeah. Okay. What is my axis of symmetry? Negative b over 2a. So x equals negative 7. Okay. My vertex, well, when x is negative 7, we already know it's going to be 0 because it's already here. So what's my y-intercept? 0, 49. Let's go by intervals of 7. 7, 14, 21, 28, 35, 42, 49. That's 1, 2, 3, 4, 5, 6, 7 to the right. Go 1, 2, 3, 4, 5, 6, 7 to the left. I know it's off my grid, but you see the point, and that's my graph. Does that make sense, gentlemen?
Wait,
Yes, sir.
this one would we need to actually do the method, or can we just do it regularly?
I don't know what you just said.
Sorry.
What does the method mean, and what does regularly mean? I don't know what that means, Papa.
You have to like this chapter. You know how you taught us?
Yeah, just like I did. I found the axis of symmetry, I found the y-intercept, and I found the x-intercept. This is the way to do it. It's not this is the normal way or the other way. This is the only way. Axis of symmetry, vertex, y-intercept, x-intercepts. Sir, thank you so much. May I erase this? Okay. Now, let's get rid of this bad boy. Okay. Last but not least, 2x, 2x. 2 times negative 36 is negative 72. What times what is negative 72? What I think is negative 21? Negative 24 and positive 3. Very good. Artificial factor of 2. So x minus 12 times 2x plus 3. So what does x equal? Nope. 12 for sure. Negative 3 over 2. Okay, guys. Again, we're having problems with a simple mathematical calculation. We have 2x plus 3 equals 0, my brothers. We undo addition and subtraction first. And then we undo multiplication with division. And that equals negative 3 halves. Does anyone have any questions on that for me, please? Okay. Thank you very much, and I hope you learned a lot. Have a wonderful day.